Hello, I'm Fernando Nunes, and next I'm going to highlight the main topics of paper Efficient Signal Quality Monitoring of GNSS Signals Disturbed by Heavy Waveforms. An heavy waveform is an anomalous signal transmitted by a GNSS satellite affected by certain types of electrical malfunctions. As a result, the shape of the code autocorrelation becomes distorted, which may lead to significant errors in the solution of the navigation equation. Three different types of heavy waveforms are usually considered: threat models TMA, TMB, and TMC, where the distortion is associated respectively with digital, analog, and digital plus analog parts of the transmitter. Since heavy waveforms occur in practice very rarely, it is convenient to resort to simulations to analyze the performance of the receivers. The main goal of this paper is to obtain explicit expressions for the distorted code autocorrelation, with different digital modulations and threat models. In particular, for TMA, the autocorrelations can be expressed in terms of sine integral functions. The Gaussian noise that affects the different correlators can also be characterized statistically and simulated using a noise generator. This constitutes the semi-analytic simulation method. As a result, important computational savings can be achieved relative to the simple Monte Carlo simulations, where noisy correlation integrals are calculated numerically by means of extensive summations. To detect the distortion of the autocorrelation peak due to an heavy waveform, the receivers are in general constituted by a bank of correlators. Several metrics can then be calculated from the correlators' outputs, namely simple ratio, difference ratio, and sum ratio metrics. The results of the semi-analytic method applied to the detection of heavy waveforms can be evaluated as follows. First, define false alarm as an event where a heavy waveform is detected although it is not present, and define missing detection when the heavy waveform is not detected although it is present. Second, assign values to the probabilities of false alarm and missing detection. And third, build plots of detectability and hazard regions. A detectability region plot for TMA is illustrated in the slide. In this example, it is not possible to detect the heavy waveform when the signal-to-noise ratio CNOT and the heavy waveform delay parameter D are simultaneously small. Thank you for your attention.